All right, guys, welcome back. This is going to be the 8.3 instructional video. And again, we're going to build off what we've talked about previously in 8.1. Remember, that was learning a rule about exponents, specifically what we do with negative exponents. In 8.3, we're going to learn another rule to deal with exponents, and then we're going to go through a bunch of examples where we solve them. Okay, so what is our rule that we're going to learn in 8.3? Well, in general, if two quantities with the same base are multiplied together, you just add their exponents. So I think an example really help us understand what we mean by this. So let me kind of set the scene here. So in general, if two quantities with the same base are multiplied together, that's what we see happening here, right? We have two quantities, we have 2 to the fourth and we have 2 to the third. They have the same base, right? They both have the same base of 2, and they are being multiplied together. Okay, so we have this scene set up. If two quantities with the same base are multiplied together, according to my rule, I should just add the exponents. I should just add the exponents and get 2 to the 7th. Okay, in general, if two quantities with the same base are multiplied together, just add their exponents, and this will be a good shortcut for finding your solution. So I have a base of 2 to the fourth times a base of 2 to the third, multiplied together. So I add the exponents, and my solution should turn out to be 2 to the 7th. Well, how can we prove this? How can we maybe see why this rule is true? Well, it's actually pretty simple. One of the concepts we've always talked about with exponents is when in doubt, write them out. Write out what the exponent means. And so let's look at what's happening here. 2 to the fourth power can be written out as 2 times 2 times 2 times 2. Okay, you have 4 2's multiplied together. So 2 to the fourth can be written out as 2 times 2 times 2 times 2. 2 to the third can be written out as 2 times 2 times 2. Okay, 3 2's multiplied together. And so what we have here is just the written out version, where this being the written out version of 2 to the third is being multiplied by the written out version of 2 to the fourth. Well, if we look at this, what do we see here? Well, what I see here is I have 1, 2, 3, 4, 5, 6, 7 2's all multiplied together. How do we shorthand write repeated multiplication of the same number? Well, whatever number is being multiplied over and over again is the base, and then the number of those numbers that is multiplied together is the exponent. Here we have repeated multiplication of the number 2, and there are 7 2's present. And so if we write out what 2 to the fourth times 2 to the third physically means, you can quickly see why the answer is 2 to the 7th. But as a shortcut, what we can do is we can just add the exponents. But again, that can only happen, and I would underline this in your notes, if you have the same base, and if you have the same base and your quantities are multiplied together. Okay? And 2 is not a all-inclusive term, right? We could have more quantities with the same base multiplied together and the rule would apply. But generally, they must have the same base and be multiplied together. So we can see that this example works. But the rule would not apply in a situation like this. Okay? Maybe we'll show you a situation where it works as well. Okay, and again, we can see the best way to see why the rule works in one circumstance and not another is to write it out. So let's write out what's happening here. X squared is x times x. X cubed is x times x times x. Versus here we have x times x times x times x times x. And what I can do in each situation is, again, usually in these scenarios, I'm trying to simplify. If I look at the top one, the written out version, there's really no simplification I can do. The simplification I can make would just lead me back to where I originally started. I have two x's multiplied together. So I can write that in simpler form as x squared, right? Repeated multiplication of the same base, plus x cubed. We have three x's multiplied together. But I cannot combine them together because they are like terms. We'll dig into this more as we go forward. But if you have the same base but different exponents, they are not like terms. And you can see that in the written out version, right? I cannot somehow combine these together. I have 1x squared and I have 1x cubed, and they're added together. Down here, though, we have a different scenario. We have 5x's all multiplied together. So the simplest way I can write this is x to the 5th power. Okay, I have 5x's multiplied together. So you can see again, why did the rule fail on the first one? Well, if we look back, we have the same base, but they are added together. They are not multiplied together. So be very careful when you're looking to apply this rule to simplify exponential functions, or in some cases evaluate or algebraic expressions involving exponents. What we want to make sure is that the quantities you're looking to apply the rule to have the same base and they are multiplied together. Okay, if one of those criteria is not met, the rule will not work. So without further ado, let's dig into some examples together. And for each of these examples, I would encourage you to pause the video, try it on your own, and then check your work with mine. So here we have 2n to the 5th times 3n to the negative 2nd. Oh, sorry, this is not the one I ready to write down. We'll do that one in a bit. Let's start with 2 to the 5th times 2 to the negative 2nd times 2 to the 4th. Okay, so what's happening here? What can we do? Well, I see I have three quantities that have base 2 and various exponents. So I have the same base, and each one is multiplied together. So I have met the criteria of my rule for multiplying or using multiplication property of exponents. That's the fancy term for the definition above. So here I can use the rule that I have learned. And what am I going to do? Well, I am simply going to add the exponents. So 5 plus negative 2 will be 3. 3 plus 4 will be 7. And again, we can see here that my answer is 2 to the 7th. Now, I'm only going to show it for this one in the interest of time in the video. But again, if you're unsure about your answer, you can always check your work. How can I check my work for this scenario? Well, again, just write out your exponents. Okay? Now, that could be a little tricky with negative exponents, but we learned in the previous video we can rewrite negative exponents in the denominator of fractions with 1 on top. Or we even learned our shortcut, where in this case, we can simplify this. We can rewrite the negative exponent by moving it to the denominator. Okay, this should be a 4. Okay, so I move that negative 2 to the denominator, applying that 8.1 rule. And then what I would do is if I really was confused, I could write the whole thing out. So I've got 5 2's multiplied together times 4 2's multiplied together divided by 2 2's multiplied together. And we know that with fractions, as long as everything is multiplied together, if everything is multiplied together on the top and the bottom as we see here, and we see the same thing on the top and the bottom, they will cancel. And when I do that, what are we left with? We are left with 7 2's, or 2 to the 7th. So again, by writing it out, we have confirmed that our rule works in this case and we have used the rule correctly. You can do that for any of these problems. Again, I'm not going to do that a ton for all of these problems for the sake of time. But again, if you want to write them out, you're more than welcome to. So let's look at a couple. Let's do another example here. 5 to the negative 2nd times 5 to the 2nd times 5 to the 0. Okay? 5 to the negative second times 5 to the second times 5 to the 0. Okay? Well, again, what I notice here is I have like bases multiplied together, so I can add the exponents. Negative 2 plus 2 is 0. 0 plus 0 is 0. So by using my multiplication property of exponents, I end up with simplifying this down to be 5 to the 0, which we know is 1. Okay? Anything to the 0 power except for 0 is 1. Okay? Again, at this point, I would encourage you, if this isn't making sense so far, go ahead and pause the video. Okay? Reach out to me. Let me know what's confusing. Well, let's try doing this with some algebraic expressions. Put up a couple here for you to try. Again, as I write each of these up, I would really encourage you to pause the video and try each example before I go through it. This will give you a good taste as to how well you're grasping the concept. Okay, when I look at the top one, what do I see here? Well, we have like bases multiplied together, so I'm going to add the exponents. I don't see an exponent for this first x, though, and when we don't see an exponent written, we know that that exponent is 1, right? This goes back to the concept that anything to the first power is just the base. So if we see just an x, we can assume it is to the first power if it doesn't have an exponent written. So I add all the exponents, and I end up with x to the 7th. Now, what about the bottom one here? This looks a little more tricky, okay? And to understand this one, we first need to understand what's happening when we see something like 2n to the 5th or 3n to the negative 2nd. And I would encourage you to think about a situation like 2x. If I asked you, hey, how are that 2 and that x attached to each other, you would hopefully tell me that they are multiplied. So apply that logic down here. Maybe we rewrite this to see it. The 2 is attached to the n to the 5th by multiplication. The 3 is attached to the n to the negative 2nd by multiplication. So we can rewrite it like this, and I'm not any closer maybe to simplifying, but hopefully by writing this out, I understand a little bit better what's going on. And why this can be especially helpful is we can use the commutative property to reorder this, because everything is multiplied together. You might not know what the commutative property is, but all that is the logic that says, hey, 3 times 4 is 12, and 4 times 3 is 12. Here we have two quantities, the 3 and the 4, that are multiplied together, and it doesn't matter what order they're multiplied in, you still get the same result. When we're multiplying quantities together, as long as everything's multiplied, there isn't any addition, subtraction in there, we can reorder it how we like. So maybe I reorder this and put the coefficients up front, and now I get a clearer picture of what needs to happen here. Okay? So all I've done is rewritten this using my understanding of some earlier math concepts. And when I do this, I quickly notice that 2 times 3 is going to be 6. I know that. And here with the n's, we have two like bases multiplied together. So I add the exponents, and I end up with n to the 3rd. Okay? So as these examples get a little bit more complex, it may be beneficial for you to rewrite each problem a couple times, making adjustments as needed, as you saw me do, writing out the multiplication symbols, putting the coefficients out front using the commutative property to help you really understand what's going on and simplify it. Let's look at a couple more examples. Okay, so looking at solving these, again, take a second, pause the video, solve them on your own. Again, for me, it's helpful to rewrite what's happening here. So I have n squared times n cubed times 7n. But what I really know is that the 7 and the n are multiplied together, and that the n is also to the first power. Now maybe I reshuffle them. Again, I like to put my coefficients out front. Again, I can do this because they're all multiplied together. Right? There's no addition or subtraction breaking this up into multiple terms. And this becomes really clear to me that the simplified version will be 7n to the 7th. 7n to the 7th. I'm sorry, not to the 7th. 7n to the 6th. 2 plus 3 plus 1 is 6. Okay, if we apply the same logic to the bottom one, again, just writing out what everything means here. Understanding that the coefficients are attached to the variables they're next to by multiplication. Reordering things. Now be careful when you're reordering things. Make sure you don't forget anything. When I do this, I see 6 times 3 times 2. Well, 6 times 3 is 18. 18 times 2 is 36. And then we have 3 like bases multiplied together. So we have the exponents. 2 plus 3 is 5. 5 plus negative 4 would just be 1. So this all simplifies down to 36y. 36y. We'll do 2 more examples together. Okay, so working these through, can reorder this top one again to have your like things together. And when I do that, I can combine my like bases, right? Like bases multiplied together, add the exponents, and I get c to the 6th, d to the negative 3rd. And while this is correct, I'm not done. And this is a trap that a lot of students fall into. You see, when we're simplifying, when we're working with exponents and algebraic expressions, we always want to make sure our answer is in the simplest form possible. So while using our knowledge of 8.3 and this multiplication property of exponents, I have simplified all the like bases multiplied together. There's still more simplification I can do. I see a negative exponent here, and I know by 8.1 knowledge that to get rid of or rewrite a negative exponent, I can simplify that and do that by writing it as a fraction with 1 on top and the d to the negative 3rd now being d to the 3rd in the denominator. Or in short, simply flipping the side of the fraction it's on. So if I have c to the 6 times d to the negative 3rd, and that we can write as a fraction by putting it over 1, right? Just like if we have the number 4, we can write it as a fraction by putting it over 1. I can simplify this by moving the d variable to the denominator in order to make its exponent positive. And I end up with c to the 6th, d to the 3rd. Okay? Again, if you're confused about why d to the negative 3rd moved to the denominator, and it became d to the 3rd, I would encourage you to watch the 8.1 videos. We cover that in 8.1 and how to work with negative exponents. But what we really see in this problem, and I'm going to put a little star by this because this is really where we're going. We're going to get to a place where to simplify algebraic expressions, we don't just use one rule, but we have to use multiple rules. Now, right now, we've only learned 2 rules. We've learned about how do we work with negative exponents and how do we work when we have like bases multiplied together. What do we do with the exponents? Our multiplication rule of exponents. Okay? And you can see we use both in the same problem. So we're going to go to a place where we have multiple different ways we could simplify things, and we're going to use multiple different rules for simplification. So be prepared as that comes. Again, when in doubt, If you're not sure if you have the answer yet, always look back and say, is there anything I can do to simplify it more? After I used my multiplication rule of exponents in this problem, there was. I could simplify the d to the negative third by rewriting it as a positive exponent by moving it to the denominator. Again, if you're not sure why I did that, check out the 8.1 video. Down here, what we see, again, I'm just going to rewrite everything. Helps my brain kind of organize things. Maybe it does yours as well. I'm going to organize my coefficients up front and align my like bases. So actually, I'm going to switch these around. And then for me, it becomes really simple as to what we have. 5 times 2 is 10. 10 times 3 is 30. We have 2 like bases multiplied together, x, which is really to the first power, because we don't see an exponent there. X to the first times x to the 8th. So those will add to give me x to the 9th. And there is nothing for the y to the 4th to combine with. It's not a negative, so it just kind of comes along for the ride. Okay, no simplification we can do with the y variable. And that will leave us with 30 times x to the 9th times y to the 4th. Or 30 x to the 9th y to the 4th being the simplified version. Guys, I hope this makes sense. Okay, are you learning about our multiplication property of exponents? You know, all we're really getting at here, if you have like bases multiplied together, you may add the exponents, but both of those criteria, the multiplication and having like bases, must be met in order to use this rule. Email me if you have any questions. Thanks for watching.